How could people survive harsh Arctic winters in houses made of wood and earth when temperatures dropped tens of degrees below zero? We imagine Viking settlements covered in snow and buffeted by icy winds. But history tells us that these communities not only survived, they thrived. Their secret was not magic, but remarkably effective engineering, where every element of the house, from the foundation to the roof, was part of a unified heat preservation system. It was not just a house, but a well-designed thermal fortress built in harmony with the harsh nature of the north. Watch the video to the end to find out how the Vikings managed to turn the frosty enemy into their ally, and why their homes were warmer than many modern buildings. I will reveal the best-kept secret. The Viking house, the famous longhouse, was not just a building, it was a living creature. The Scandinavians, who spent half their lives at sea, transferred the principles of shipbuilding to land, creating a unique architectural form. These houses, which reached lengths of 30 and sometimes 80 meters, had walls curved like the sides of a drakkar. This shape was chosen not for beauty, but to combat the merciless northern winds, allowing air currents to flow around the structure rather than hitting it with full force. The entire life of the community was concentrated under one giant roof. In this huge space, there was no division into rooms in the modern sense. Everyone lived here, the head of the family, his relatives, workers, and even slaves. Such collective living was not only a social necessity, but also an important element of thermoregulation, since dozens of people in one enclosed space generated a significant amount of heat. The longhouse, or langhus, was designed as a single organism, a self-sufficient ark capable of withstanding many months of winter. Its construction was oriented according to the cardinal directions in order to minimize heat loss. The entrances were almost never located on the end walls, which bore the brunt of the elements, but were hidden in long side walls, often with special extensions. The walls of this earthship were massive and multi-layered. The Vikings did not rely solely on wood, which was a valuable resource in the harsh climate, but not the best insulator. They created a complex sandwich of materials, where each layer performed its own function, turning the dwelling into something like a modern thermos. This technology had been refined over centuries and allowed precious heat to be retained inside. The foundation was a strong wooden frame made of vertical posts that supported the entire weight of the massive roof. These posts, often made from solid pine or oak trunks, were dug deep into the ground. The space between them was filled not with thin boards, but with much more effective materials provided by nature itself.
We need more wood for the fire.
The stew is almost ready, Ragnar.
Skål. May your harvests be plentiful.
We would love to hear your opinion. What do you think about this concept of a ship house, where the entire community lives under one roof, like a single crew? Write about it in the comments. And be sure to subscribe to the channel so you don't miss our next episodes about technologies of the past. Are you ready to learn the truth about what the Vikings actually used to build their wooden houses? When we hear Viking house, we imagine a log cabin similar to those built in wooded areas. However, in many regions, such as Iceland or Greenland, wood was incredibly scarce. Therefore, the Vikings developed a technology that minimized the use of wood, relying on other, much more accessible materials. The foundation of the house was the frame. This was the only part where wood was indispensable. Strong pillars made of oak, pine, or birch formed the skeleton of the building. This skeleton bore the entire load of the roof and walls. But the walls themselves were not wooden in the sense we are familiar with. They were more like earthen walls, which was the main secret of their thermal efficiency. Before erecting the frame, the Vikings prepared the foundation. They laid out a line of large, flat stones around the perimeter of the future house. This stone belt served two important functions. First, it leveled the ground, and second, more importantly, it insulated the wooden frame from the damp earth, preventing the wood from rotting. Wooden posts were placed on this stone foundation. The space between them was filled with the most important insulation material of the Viking era, turf. Turf, or peat, consisted of layers of earth tightly bound together by grass roots. It was cut into large rectangular blocks, similar to giant bricks. These sod bricks were stacked on top of each other to form incredibly thick walls. The thickness of such a wall at the base could reach 1.5 and sometimes even 2 meters. The wall narrowed towards the top, which gave it additional stability. The blocks were often laid in a herringbone pattern or interlocked to ensure maximum density and no gaps. Such a turf wall had phenomenal thermal insulation properties. The porous structure of the soil, permeated with roots, retained many small air pockets. It was this immovable air that was the best insulator, working on the same principle as modern foam plastic or mineral wool. Turf was a living material. In the spring, the outside of such a wall was covered with grass, which made the house look like a natural hill, blending completely with the landscape. This grass further strengthened the wall, binding the turf blocks with new roots. The house literally became part of the earth.
See how the hillside embraces our home, safe from prying eyes and the winter winds.
How effective do you think this combination of natural materials was compared to modern ones? But what if I told you that fire was not the only source of heat in the house? In the next chapter, we will reveal the secret of living heating used by the Vikings. What I am about to show you was normal for the Vikings, but shocking to modern people. They shared their homes with dozens of animals. This was not a sign of savagery or poverty, but an ingenious engineering solution that saved fuel and allowed them to survive the harshest winters.
How did people survive the brutal Arctic winters in homes made from little more than wood and earth, when temperatures plummeted far below zero? Picture Viking settlements blanketed in snow, lashed by icy winds, and yet history shows us these communities didn't just survive, they thrived. Their secret wasn't magic, it was ingenious engineering. Every part of a Viking house, from the foundation to the roof, worked together as a unified system to preserve heat. These weren't mere shelters, they were thermal fortresses, carefully designed to turn the harsh northern climate into an advantage rather than a threat. The legendary Viking longhouse, often seen as just a dwelling, was much more. It was a living, breathing structure. Vikings, who spent much of their lives at sea, borrowed principles from shipbuilding to craft their homes. Some of these longhouses stretched 30 meters, even up to 80, with walls curved like the hulls of a ship. This wasn't for aesthetics. The curved shape allowed wind to flow smoothly around the house instead of battering it, reducing heat loss and structural strain. Inside, the longhouse functioned as one enormous communal space. There were no separate rooms like in modern houses. Everyone, family, workers, and even slaves, shared the same roof. This collective living arrangement wasn't just social, it was a crucial part of the house's heat management. The body heat from dozens of people living together created a natural, shared warmth that helped the house endure even the harshest winters. These structures were designed as single, self-sufficient organisms, almost like a living ark built to weather months of cold. Orientation mattered. Longhouses were positioned according to cardinal directions to reduce heat loss, with entrances tucked into the sides rather than facing the brutal wind head-on. The walls themselves were a marvel of Viking ingenuity.
The longhouse was not just a dwelling for people, it was also a winter barn, and these two functions were inextricably linked. The interior of the house was clearly divided into two areas, living and working. About half, and sometimes more than half, of the house was occupied by stalls for livestock. Cows, sheep, goats, and horses. the main wealth of any Scandinavian family, spent the winter here. The lack of separate buildings for livestock was not a whim, but a well-thought-out survival strategy. The living area and the barn, or feops, were usually separated by a simple wooden partition. This partition was not airtight. It only marked the boundary, but allowed air and heat to circulate freely between the two parts of the house. People and animals actually breathed the same air under the same roof. The secret of this system lay in simple physics. Any large animal, such as a cow, generates a huge amount of heat during its life. A dozen cows in an enclosed space is a complete heating system, operating around the clock and completely free of charge. The heat generated by livestock was as important a resource as firewood or peat. The floor level in the living area of the house was often slightly higher than in the barn. This was done not only for hygiene reasons, to prevent waste from the barn from entering the living area. Warm air from the animals, following the laws of convection, rose and naturally moved to the higher living area of the house, mixing with the heat from the hearth.
The warmth holds well tonight.
It does.
The animals benefited no less from this proximity. In a harsh climate, a separate barn would freeze through, which would lead to the death of the livestock. Being under the same roof as people and receiving some of the heat from the hearth, the animals were reliably protected from the cold. It was a true symbiosis, beneficial to both sides. Of course, such a neighborhood had its drawbacks, the main one being the smell. However, for the people of that era, the smells of livestock were a familiar part of life, and did not cause the same revulsion as they do for modern city dwellers. Warmth and survival were much more important than olfactory comfort. In addition, the constant work of the hearth and the smoke from it partially neutralized the smells. If you think this method is ingenious in its simplicity, like this video. And be sure to subscribe to the channel so you don't miss new videos about how people survived in the harsh conditions of the Middle Ages.
Come closer to the fire, my love.
This airlock system, or heat trap, was incredibly effective. It prevented the icy wind from rushing straight into the heated room.
It is so warm by the fire.
While a person was in the vestibule, they had time to shake the snow off themselves. Thus, the cold and moisture remained behind the second barrier. The location of the entrances was also not accidental. They were almost never placed opposite each other to prevent drafts from blowing through the house. Most often, the entrances were located in long walls protected from the prevailing winter winds. Sometimes the entrance was additionally protected by a protruding part of the wall or an earth embankment. Can you imagine what it was like to live in almost complete darkness for months? In the next chapter, we will talk about the heart of the house, the source that provided not only heat, but also the only light. The heart of the longhouse, its sole and main source of life, was the central hearth. Unlike the compact stoves or fireplaces we are used to, the Viking hearth, or langolder, was a long, shallow pit that stretched along the entire central axis of the living area of the house. It could be up to 10 to 15 meters long, which allowed it to heat a huge space.
I remember a winter colder than this, when the fjord froze solid for 3 moons. We hunted the great white bear upon the ice.
This hearth was not just a fire on the floor. Its edges were lined with large stones, which served several functions. First, they prevented the fire from spreading. Second, the stones accumulated a huge amount of heat and then slowly and evenly released it into the space, acting as a large heating battery. Wood was the main fuel, but in treeless regions such as Iceland, peat was widely used. Peat burned slowly, gave off even heat, and was available in abundance. Harvesting peat for the winter was one of the most important tasks of the community, as survival depended directly on it. The long fire was a multifunctional device. First and foremost, it was a source of heat. Its elongated shape allowed the heat to be distributed evenly throughout the living area. People sat on benches along the walls, and everyone received their share of precious heat from this central heater.
A fine blaze tonight.
It warms the soul as well as the body.
The second most important function of the hearth was light. In a windowless house, the langgelder was the only source of illumination. The flickering flames illuminated the faces of people, carved wooden pillars, and wisps of smoke under the ceiling. All life in the house was concentrated in this illuminated space. Of course, the hearth was also the kitchen. Large cauldrons were suspended over the fire on special chains or tripods in which food was prepared for the whole family. Here they cooked soups, porridges, and roasted meat. The smell of cooking mixed with the smell of smoke and livestock, creating the unique atmosphere of a Viking dwelling. What if I told you that the Vikings did not have chimneys, but they did not suffocate from smoke? The presence of a huge open hearth in the center of the house posed a difficult task for builders. How to remove the products of combustion without losing all the heat? The solution to this problem was as simple and ingenious as the entire design of the house.
The fire is strong tonight.
Aye, keeps the cold spirits away.
Pass the horn, brother.
The brick pipes and chimneys we are familiar with did not exist in those days. Smoke from the long fire rose freely, accumulating under the roof itself. The entire upper space of the house, above human height, was filled with a dense, hot, and acrid layer of smoke. This had an unexpected positive effect. Hot smoke and soot constantly saturated the wooden beams of the roof and rafters. This process, similar to smoking, was an excellent preservative. It killed wood-boring beetles and protected the wood from rotting, significantly extending the life of the structure. Of course, the smoke had to go somewhere. For this purpose, special holes were made at the highest point of the roof, directly above the hearth. These holes, called ljora, served both for ventilation and lighting. It was the only source of daylight in the house, apart from the open door. The ljora was not just a hole in the roof. It had a special design that allowed it to be adjusted. Most often, it was a wooden frame that could be partially or completely covered with a special shield or cover. This cover was controlled by a long pole standing by the hearth. Controlling this damper was a real art. In winter, it was kept almost completely closed, leaving only a small gap. This allowed the thickest smoke to escape, but kept as much warm air inside